Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to discuss about finite state machines. So in finite state machines are again classified into two types. First one is Mealy FSM and followed by we have Moore FSM. So finite state machines are classified into two types. One is Mealy FSM and another is Moore FSM. Let us try to understand what do you mean by Mealy FSM and what do you mean by Moore FSM in great detail. Let us see the difference, exact difference. What do you mean by Mealy FSM and what do you mean by Moore FSM? So in the case of Mealy FSM, your output is dependent upon both the input and the current state of the circuit. In the case of Mealy FSM, your next state is dependent on the input as well as the current state. In the case of Moore FSM also, next state is dependent upon the both input as well as current state. In the case of Mealy FSM, your outputs are asynchronous, whereas in the case of Moore FSM, your outputs are synchronous. So these are some of a few differences between your Mealy FSM and Moore FSM. Now let us try to see the state diagrams of this Mealy FSM and Moore FSM. Now let us try to see the state diagram, how to represent this Mealy FSM state diagram. So this Mealy FSM state diagram will look like this. Suppose there are three states S1, S2 and S3, and if we want to represent the states using Mealy FSM, then it will look like this: S1. This S1, S2, S3 are your present states. And the arrow mark here from S1 to S2 and from S2 to S3, or from the self arrow mark, okay, or from S2 to S1, okay. This represents your next state. This arrow marks represents your next state. Now, where to represent your inputs and outputs? So, in the case of Mealy FSM, we are going to represent our input with the arrow mark followed by your output. So, input is declared first, followed by your output. So, input followed by output. So, in the case of Mealy FSM, we are going to represent our output with input. As a definition, we already know your output is only dependent upon the input as well as present state. So, that's why in the case of Mealy state machine, we are going to represent our output with the input. Now, let us discuss about another type of state machine which is known as Moore FSM. Let us try to discuss what is mean by this Moore FSM. So how your state diagram will look like in the case of Moore FSM. So let's say again we have three states S1, S2 and S3. So we will represent the states S1, S2, S3, where this S1, S2, S3 are your present states. S1, S2 and S3 are your present states. We already know this arrow marks represent your next states. This arrow mark is showing you to which state you are going to. Okay. Now, here in the case of Moore FSM, we are going to write the input here and the output we are going to mention with the state. We are going to mention the output with the state. So this is the difference between the state diagram of your Moore FSM and the Mealy FSM. Where in the case of Mealy FSM, we are going to represent our output with the input, whereas in the case of Moore FSM, we are representing our output with the state. Now let us try to see some examples of sequence detectors. Sequence detectors. Let us try to understand what do you mean by a sequence detector. Let's say for example, we have a circuit. Let's say for example, we have a circuit which is a sequence detector, which has some set of inputs, clock, since it is a sequential circuit, reset, data in, and data out. Okay. So this particular sequence detector circuit has this set of inputs, clock, reset, data in, data out. This data in, it is a serial in. This data in, it is a serial input. That is, for every clock you are going to, for every clock edge you are going to provide this particular serial input. Okay, clock by clock you are going to provide this equal serial input. Now let's say this is not data out. Let's say it is detected. Detected. The signal detected will be equal to 1 if the required sequence is being applied in the data in. For example, if the sequence detector is expecting the data in as 001, if this particular sequence 001 has been arrived in the data in, then your detected signal will be equal to 1, or else your detected signal will be equal to 0. So let us try to design your Mealy FSM, for this particular sequence detector, which is going to detect the sequence 001. Okay, and please remember, for every clock edge we are going to get one signal. It is not a parallel input data. It is a serial data. For example, this is your clock edge. This is your clock pulse. So at first clock edge, we will get the sequence, and we will get the bit 0, and at the second clock edge we will get the input 0 and followed by 1. So like this we will get our data. So before going to discuss about Mealy FSM for this particular sequence detector, so sequence detection is of again classified into two types. We have non-overlapping sequence detector and overlapping sequence detectors. So totally we have two type of sequence detectors. One is non-overlapping sequence detector and another is overlapping sequence detector. Let us try to understand the difference between non-overlapping sequence detector and overlapping sequence detector. So first let us try to understand how your non-overlapping sequence detector works. Then we'll come back to overlapping sequence detector. So let us try to take an example. Let's say our sequence detector is expecting a sequence 101. Okay. Our sequence detector is expecting a sequence 101, and if this particular sequence has been arrived at the input, then your data out will be equal to 1. Sorry, detected will be equal to 1, or else detected will be equal to 0, which is the output. Okay. That is our requirement. Let's say at the input we are getting this particular sequence as 0 0 1 0 1 0 1 0 0 0. Okay, we are talking about the case non-overlapping. Okay, now what is your output in this particular case? So let us try to write down the output. So here your output will be equal to 0. Here also your output will be equal to 0 0 0, and since the sequence has been detected 101, your output will become 1 in this particular case. Since the sequence has been detected 101, your output will become 1 here. Okay, since the sequence has been detected, now we will start checking the sequence again from the fresh bit. We are not going to consider the previous bit. We are going to start sequence checking from this bit. Okay, so here your output will become 0 and your output will become 0 only. It will be 0 up to this. We are not going to consider this one. We are not going to consider this one, and we are not going to say this is 101, so our sequence has been detected. No. Since the first sequence has been detected, we are going to start the sequence checking from this next bit. Okay, we are not going to consider the previous bit in the case of non-overlapping. So this is the output for in the case of non-overlapping. Now let us try to see the output for your overlapping output. So in the case of overlapping also, here you will get 0 only, output as 0, and since the sequence has been detected 101, you will get the output as 1. Now in the case of overlapping, you can consider the previous bit and you can form a sequence like this. You can consider the previous bit and you can form a sequence. So that's why in the case of overlapping, you will get your output as 1 here. In this case, you are going to get your output 1. But in the case of non-overlapping, see, we are not getting our output as 1 because we are not allowed to consider this bit from the previous sequence. But here in the case of non-overlapping, we can consider it. Okay, this is the difference between your overlapping and non-overlapping. So this is a case of overlapping. So for this, we are going to design your Mealy FSM and Moore FSM. First, let us try to design your sequence detector for the sequence 101. Let us try to design this Mealy non-overlapping sequence detection 101. Okay. So let us try to decide how many states should we have. So let's say we have one state which is known as idle. Okay, so this state, in this particular state, no sequence has been detected. This state stands for no sequence detected. And one more state, S1, where one bit has been detected, one bit detected. And S2, two bits. So after the 3 bits has been detected, then there is no need to go to S3 state. You can come back to idle state. Okay. So let's see the diagram for this Mealy non-overlapping FSM. So we have 3 states. One is idle and another is S1 and S2. Okay. So this is idle state, S1 state and S2 state. Now after applying reset signal, we are coming to idle state. So our sequence, our required sequence is 1, 0, 1. This is the required sequence. And I'm going to consider my checking of sequence from MSB to LSB. I'm going to consider the sequence checking from MSB to LSB. Okay. Now, if my first bit is 1, if my input bit is 1, then from idle state, I'm going to S1 state. If my input is equal to 1, when I'm in idle state, I'm going to S1 state from the idle state, making my output still remaining to 0. Okay. Or else, if I'm in idle state and if my input is equal to 0, then I'm going to stay in the same state. My output is equal to 0. Since S1 stands for 1 bit detection, so that's why if 1 is my input, if I'm in idle state that is matching with my sequence, only 1 bit is matching, so that's why I'm going to S1 state, or else I'm going to stay in the same state. Now in the case of S1 state, again we have two possibilities. One is you can go to S2, or you can, and when we are in S1 state, we have two possibilities, whether your input can be equal to 1 or whether your input can be equal to 0. Let's say if your input is equal to 1, if you are in S1 state, you have already input one of the bit given as 1, and if you are in S1 state, one of again you have got 1. Okay, if you are in S1 state, again you have got 1. So you have got the sequence 1 1. But your required sequence is 101. You have got the sequence 1 1, but your required sequence is 101. So you cannot proceed to next state S2. What you can do is you can go to either idle state or you can stay in the same state. So if you stay in the same state, you can reutilize this 1 bit and you can build this 101. So that's why what I'm going to do is I'm going to stay in the same state with my output equal to 0. Now, if my input is equal to 0, I have already a sequence 1. I have already got a bit 1 because I am in S1 state. And if my next bit is equal to 0, and if my next bit is equal to 0. So, these two bits are matching with my sequence. My sequence is 101 and two bits are matching. So, that's why I am going to S2 state, which is a 2 bits matching state, but I am making my output is equal to 0. So, S2 state is nothing but 2 bits detected state. If I am in S2 state, I have already the sequence 101. Again in S2 state, I have two possibilities, whether my input can be equal to 0 or whether my input can be equal to 1. Whether my input can be equal to 0 or whether my input can be equal to 1. If my input is equal to 0, my sequence will be 100. If I'm in S2 state and if my input is equal to 0, then my sequence become 100, which is not completely matching with my 101 sequence. So that's why simply I'm going to idle state from S2 state if my input is equal to 0, making my output to 0. Okay. Now, if I am in S2 state and I am already having the sequence 1 0, and if I get one more 1, that is my sequence is matching. So definitely I can make my output to 1. But to which state I should go? Since we are discussing Mealy non-overlapping, and the example which we have seen, if your sequence has been detected, your output should be 1, and you cannot use this 1 to build one more sequence. That is, you cannot reuse this particular 1. So that's why what I'm going to do, I'm simply going to idle state. If my input is equal to 1, output is equal to. So this is how we are going to draw the sequence detector for the sequence detection 101 using Mealy FS. Now let us see the sequence detection of overlapping sequence. So let us try to understand Mealy overlapping sequence detection for the sequence 101. So again we have, if we apply our reset signal, we will come to our idle state. Let us consider the same states only, and S1 state and S2 state. So if we apply our reset signal, we will come to this ideal state. And if again, we will consider this. So if your input is equal to 0, in the case of ideal state, you are going to stay in the same state and your output is equal to 0. And if your input is equal to 1, if you are in ideal state and if your input is equal to 1, then you are simply going to S1 state and your output is equal to 0. Now, and if you are in S1 state and if your input is equal to 1, you are going to stay in the same state with your output is equal to 0. Okay. And if you are in S1 state and if your input is equal to 0, you are going to S2 state by making your output to 0. Now, here the major difference lies. If you are in S2 state and you have already the sequence 1 0, and if you got one more 0 which is completely mismatching. Now if you are in S2 state, you have already 1 0, and if your input is equal to 0, it is completely getting mismatched with your particular sequence 101. So using this sequence you cannot build further any sequences. So that's why what you are simply going to do is you are going to idle state by making your output to 0. But if you are in H2 state, you have already the sequence 1 0, and if you got one more 1, then in the case of Mealy FSM, if you observe, you are going to idle state. But here, since we are talking about overlapping sequence, we can use this 1 to build the sequence 101 again. We can reuse this particular one. In the example which you have seen in the starting, we can reuse this particular one for building the sequence. So that's why what I'm going to do is from S2 state, I'm going to S1 state, and by making your output to 1. So this is Mealy overlapping sequence detection for the sequence 101. Now let us try to see one more sequence detection. Let us try to see Moore sequence detector, Moore FSM for the sequence 101, Moore non-overlapping sequence detection, Moore non-overlapping for the sequence 101. Let us try to see Moore non-overlapping sequence detection for the sequence 101. So again, we are going to consider the states: ideal state, S1 state, S2 state. Ideal state is no bit matching. And S2 state is 2-bit matching. But here, in the case of Moore FSM, we will have one more state. We will consider one more state, 3-bit matching state, S3. Why? The reason I will show you now. So I will draw them. So one is ideal state, S1 state, S2 state, S3 state. And here the ideal state, you are going to mention the output with the state only. So you know the output is equal to 0 because no bit is matching. And S1 state also we know no bit is matching, so your output is equal to 0. And S2 state also no bit is matching, so that's why your output is equal to 0. And in the S3 state, your output is getting matched, so that's why it is equal to 1. So that's why we need this particular extra state so that we can represent our output with this. Now, so again, same pattern 101, and we are going to consider non-overlapping, Moore non-overlapping. So if we apply our reset signal, we will come to this ideal state, and if our input is equal to 1, we will simply go to S1 state. But if our input is equal to 0, when we are in ideal state, we are going to stay in the same state. If you are in S1 state and if your input is equal to 1, same as your Mealy FSM, you are going to stay in the same state because you can reuse this particular one. But if your input is equal to 0 when you are in S1 state, you are going to S2 state. When you are in S2 state, you have already the sequence 1 0. When you are in S2 state, you have already the sequence 1 0. And if you get one more 0, then this particular sequence is not matching with 1 0 1. So that's why you are simply going to ideal state if your input is equal to 0. But if your input is equal to 1, which is matching with the required sequence 101, So that's why you are going to S3 state. Now, if you are in S3 state, you have already got the sequence 101, and if you get one more zero, if you get one more zero, actually you can reuse this 10 for building the sequence again. But since we are discussing about non-overlapping sequence, that's why what we are going to do, if we get our one more zero, we are simply going to idle state. If we are in S3 state, let's talk about another possibility. If we are in S3 state, we have got the sequence 101, and if we get one more one, we can use this one for building the sequence. We are not considering the previous sequence bit, we are considering the fresh bit only. Okay, so that's why we are going to S1 if your input is equal to 1. So this is how we are going to design a Moore non-overlapping sequence detector. Now let us try to design your Moore. Again, we are going to consider the same states: idle. So these are your states. Now if you apply your reset, then you are going to idle state. And from the idle state, if you get and from the idle state, if you get 0, you are going to stay in the same state. And if you get one more 1, you are going to S1 state. And if you are going to get 0, you are going to S2 state. And if you get one more 1, you are going to stay in the same state that we already know. We are discussing it from a long time. And if we get one more 1, we are going to S3 state 101, and in the H2 state we have already the sequence 10, and if we get one more 0, there is no use. This is not matching with your 101 sequence, so that's why you are going to idle state simply. Now if you are in S3 state and you have got the sequence 101, and you if you get one more 0, then you can reuse this 10 for building one more sequence. So that's why you are going to S3 from S2 if your input is equal to 0. And if you are in S3 state, you have already got the sequence 101, and if you get one more one, you can reuse this particular one, okay, for building the sequence. So that's why you are going to S1 state when your input is equal to 1. So simply see here, in the case of 101, in the S3 state we have 101, and if you get 0, we can use this 10 for building 101 again. So that's why we are coming to S2 state. But in the case of 1, we are coming to S1 state. So this is Moore overlapping sequence detection. Now let us try to increase the difficulty of this particular sequence detections. Let us try to consider different cases. So this is case 2 which we are going to deal. So in this particular case 2 we have two sequences that should be detected. Two sequence detections. Let's say if we have to detect two sequences, one is let's take a simple sequence 101 and 011. Okay, these are the two sequences that should be detected, and if any one of the sequence has been detected, your output should be equal to 1. But here also again we have overlapping and non-overlapping. We have non-overlapping and another is overlapping. So let us try to discuss this overlapping and non-overlapping. So let us try to understand the example of non-overlapping first. Let us have a sequence 0 0 0 1 0 1 1 0 0 0 1. Okay, let's say this is our sequence. Now coming to your output will be equal to 0, since no sequence has been detected till now. Here also your output will be equal to 0, and since the sequence 101 has been detected, your output will become 1. That's it. And since we are talking about non-overlapping, we should not consider the bits of the previous sequence. So that's why we are not going to make here the output as 1. You might say, sir, we have detected 0 1 1, so our output should be equal to 1. No, we are talking about non-overlapping. So the sequence, bits from this previous sequence we cannot consider. So that's why our output is equal to 0 here. And here also we are going to get our output to 0, 0 and 0. So this is non-overlapping sequence. Let us see your overlapping sequence. So again we will take 0 0 0 1 0 1 1 0 0 1. Okay. So this is our sequence, and let us try to see the output for this overlapping. Okay, this is a case of overlapping. So in the case of overlapping, again your output will be equal to 0 up to here, and your output will be 1 since the sequence has been detected here 101, your sequence has been detected. And here also your output will be equal to 1. Since it is an overlapping sequence, you can consider the previous bits from the sequence, that is 0 1 1. You can consider the previous bits also. Again, that's why your output is becoming 1 here, and remaining all your output will be equal to 0. Your outputs will be equal to 0 up to here. So this is the difference between overlapping and non-overlapping in the case of two sequences. If we have to detect two sequences, this is the difference between your overlapping and non-overlapping. So let us try to design your sequence detector. First, let us try to design your Mealy sequence detector. Then we'll come back to Moore's sequence detector. So Mealy non-overlapping. Let us try to design this Mealy non-overlapping. So let's say if we are applying our reset signal, we are simply coming to a state which is known as idle state, where no bit has been detected. Okay, so we have came to idle state where no bit has been detected. Now if we are in idle state, we have two options: either your input may be equal to 0 but your output is still 0, and either your input may be equal to 1 and your output is still 0. Okay, so let's say the state name is S1 and this state name is S2. Now from the S1 state, you have 1 0. So we have two sequences, right? One is 1 0 1 and another is 0 1 1. 1 0 1 and another is 0 1 1. So if we get 0 followed by one more 1. So if we get 0, we are in S1 state, and if we get one more 1, then we will simply go to S2 state. If we get 1, your output will be equal to 0. And if you are in S2 state and if your input is equal to 1 and if you get one more 0, you are going to get, sorry, this is S3 state, and we are going to S4 state. Okay, now one possibility has been completed. From S1 to S3, if your input is equal to 1, you are going. But what if your input is equal to 0? So in this particular case, you are going to stay in the same state by making your output to 0. You can reuse this particular 0, right? And if your input is equal to 1, you are going to stay in the same state by making your output is equal to 0. Now if you are in S3 state and if you have already the input 0 1, and if you get one more 1, and if you are getting one more 1, you are simply going to idle state. You are simply going to by making your output to 1. Why? We can reuse this one for building 101, sir. Why we are going to idle state? Because if you see, we are discussing about non-overlapping, because we are discussing about non-overlapping. If we get the sequence 0 1 1, we will not reuse that particular bit again. Okay, so that's why we are going to idle state. And if we get one more 0, so this is the case of 1, but if we have the sequence 0 1 and if we are in S3 state, if we are having the sequence 0 1 and if we get 0 1 0, okay, we can use this 1 0. We can use this 1 0 since the sequence has been not detected. 0 1 0 is not matching with your 0 1 1, and you can reuse this 1 0. So that's why which state you are going to. From S3 state you are going to S4 state. This S4 state is having already the sequence 1 0. So that's why you're going to S4 state if your input is equal to 0 and your output is still 0. Now if you are in S4 state and you're having a sequence 1 0, and if you get one more 0, this 1 0 0 is not matching with your 1 0 1 sequence. But you can use this 0 for building 0 1 1. So that's why you are going to S1 state with when your input is equal to 0 and your output is equal to 0. But if you are in S4 state, you are having the sequence 1 0, and if you get one more 1, then your sequence has been detected and you will simply go to idle state if your input is equal to 1 by making your output to 1. So this is how we are going to design a Mealy sequence detector for non-overlapping multiple sequences. Now let us try to design your Mealy overlapping sequence detector for multiple sequences. Those are 101 and 011. So again, if we apply the reset signal, we will come to idle state. And if we are in idle state, if we get 0, we have one option, and if we get 1, we have another option. So we can go to S1 state, and here we can go to S2 state, but your output is equal to 0 and your output is equal to 0. And now in your S1 state, if you get one more 0, you are going to stay in the same state, and in the S2 state, if you are going to get one more 1, you are going to stay in the same state. That we already know in the previous example. And if we get one more 1, we are going to S3 state. And if we get one more 0, we are going to S4 state. Okay, this we have already seen. Now, if we get 0, 1 followed by one more 1, we were going to ideal state in the case of non-overlapping. So if we are in S3 state, we have already the sequence 0, 1, and if we get one more 1, in the previous case we were simply going to ideal state. But this is the case of overlapping, so that's why you can consider this particular one for building the sequence 101. Using this particular bit 1, you can build the sequence 101. So that's why what you're going to do from S3 state, you're going to S2 state if your input is equal to 1 by making your output. If you are in S3 state, you are already having the sequence 0, 1, and if you are another possibility, that is input is equal to 0. Previous case, you are simply going to S4 state, and in this case also, you are going to S4 state. If your input is equal to 0 and output is equal to 0. Now, we'll see this bottom one. So if you are in S4 state, you are already having the sequence 1, 0. And if you are having one more 0, in the previous case, you are simply going to, so in the previous case, you are going to S1. In this case also, there is the same option. You will simply go to S1 state. If your input is equal to 0, output is equal to 0. And if you are in S4 state and you are already having 1, 0 sequence, and if you get one more 1, you can reuse this 0, 1 for building 0, 1, 1. So that's why where you are going to S3 state if your input is equal to 1 and making your output to 1. So this is how you are going to design a Mealy overlapping multiple sequence detections.